Section 1. Introduction. TensorFlow in 2025. Still a titan in the AI arena. Why should you still pay close attention to TensorFlow in 2025? The machine learning landscape moves at a breathtaking pace, yet some foundations remain critical. TensorFlow continues to be one of those foundational pillars powering a significant portion of the world's AI vast recommendation engines at global tech companies, tiny intelligent sensors in your home. It's engineered for production, delivering speed stability, a mature ecosystem. The 2025 updates are not just incremental, they leap forward in usability, performance, interoperability, reaffirming TensorFlow as a go-to for real-world ML solutions. TensorFlow is a comprehensive open-source platform for building and running ML models. It gives developers a complete toolkit to move from a conceptual idea to a scalable, production-ready application. Train sophisticated deep learning models on massive datasets. Deploy them across multiple environments, powerful cloud servers, everyday mobile phones, tiny microcontrollers. This end-to-end capability makes TensorFlow a reliable workhorse beyond research. The 2025 release adds powerful features to meet modern ML challenges: key enhancement, Keras 3 integration, JAX support, PyTorch support. Training performance gets a major boost through XLA compilation advances, simplified distributed training with DT Tensor for deployment. TensorFlow serving evolves for high throughput, low latency inference, TensorFlow Lite on edge devices, TensorFlow.js in the browser. Section 2. The Keras 3 revolution, simplicity, and multi-backend freedom. The most significant change in TensorFlow for 2025 is the full native integration of Keras 3 as its default high-level API. Keras has always been praised for its user-friendly and modular design, allowing developers to build complex neural networks with simple, composable blocks. With Keras 3, this simplicity reaches a new level of refinement. The API for defining layers, compiling models with losses and metrics, running training loops, has been further streamlined. This means you write fewer lines of boilerplate code and can focus more on the architectural design of your model. For anyone building models, this translates into faster development cycles and code that is significantly easier to read, share, and maintain over time. A groundbreaking feature of the Keras 3 integration is its native multi-backend support. Historically, choosing a deep learning framework was a major commitment that locked you into a specific ecosystem of tools and workflows. In 2025, that is no longer the case. You can write your model code once using the Keras API, and then seamlessly execute it on different computational backends, TensorFlow, JAX, PyTorch. This flexibility is a game changer for collaboration and experimentation. A research team might prefer the JAX backend for its powerful function transformations, while the deployment team can run the exact same model on the highly optimized TensorFlow backend for production serving, all without rewriting the core logic. For example, you might leverage a state-of-the-art model component written in PyTorch by another team, integrate it into your Keras-based architecture, and still deploy the final artifact using TensorFlow's robust serving infrastructure, future-proofing your work and preventing vendor lock-in. Section 3. Accelerated performance, blazing fast training, and cost efficiency. Speed is a currency in machine learning, and faster training means more experiments, better models, and lower costs. TensorFlow 2025 doubles down on performance with major enhancements to its graph compilation capabilities, primarily through the XLA, Accelerated Linear Algebra, compiler. By simply enabling XLA, TensorFlow can analyze your model's computational graph, fuse multiple operations into single, highly optimized kernels, and perform sophisticated optimizations that are specific to your hardware, CPU, GPU, TPU. This process happens automatically under the hood, often resulting in significant speedups and reduced memory consumption without requiring any changes to your model code. The benefits of graph mode and XLA compilation are especially pronounced for large models and long training runs. When operations are fused, the framework makes fewer calls to the underlying hardware, reducing overhead and allowing the GPU to stay saturated with meaningful work. For example, a sequence of element-wise additions and multiplications can be combined into a single, efficient computation. This not only makes the math run faster, but also lowers memory usage by eliminating the need to store intermediate results. For organizations operating on a budget, this directly translates into lower cloud computing bills, as you can achieve the same results with fewer compute hours. Another critical tool for cost control is the expanded support for mixed precision training. Modern GPUs like NVIDIA's Tensor Core GPUs are specifically designed to perform calculations with 16-bit floating point numbers, FP16, much faster than with traditional 32-bit numbers, FP32. With a few lines of code in Keras, you can enable mixed precision, which instructs the framework to strategically use FP16 for most calculations while keeping certain sensitive parts like weight updates in FP32 to maintain numerical stability. This technique can often provide a 2 to 3 times speedup on compatible hardware and halve the memory footprint of your model. Section 4. Scaling effortlessly from distributed training to production. Serving training, today's massive models, large language models, LLMs, high-resolution vision transformers requires more than a single GPU. It demands distributed training across multiple devices and even multiple machines. TensorFlow 2025 simplifies this with dTensor, a new high-level API for distributed computing. dTensor lets you express your sharding strategy, split your model and data across available devices. Write your model code as if on a single giant device. dTensor handles underlying complexity data, parallelism model, parallelism communication between shards, making large-scale training more accessible. Once your model is trained, the next step is deploying it to serve predictions to users. TensorFlow serving, the gold standard solution enhanced for greater efficiency and ease of use, a high-performance serving system for production capable of handling millions of requests per second with low latency, works with the saved model format, seamlessly move models from training to serving advanced feature. Request batching for teams needing a structured, repeatable path to production TFX. A complete end-to-end MLOps platform, data ingestion and validation, pushing the validated model to serving a cohesive ecosystem for ML at scale. Section 5. AI on every device, mastering mobile, web, and the edge. The power of AI is most profound when it runs directly where the user is, providing instant, private, and offline capable experiences. TensorFlow 2025 continues to lead the charge in on-device machine learning with TensorFlow Lite, TF Lite, a lightweight framework for deploying models on Android, iOS, embedded Linux systems, tiny microcontrollers. TF Lite is designed to optimize models for low-latency inference and a small memory footprint. A key feature is post-training quantization, a process that can reduce a model's size by 2 to 4 times and significantly speed up CPU execution by converting its weights from 32-bit floating point numbers to more efficient 8-bit integers with minimal loss in accuracy. This capability is transformative for a wide range of real-world use cases. In computer vision, a developer can take a pre-trained model for object detection, fine-tune it on a custom dataset, and then convert it to TF Lite format to run in real time on a smartphone camera feed, allowing an app to sort photos or identify products without an internet connection. In speech recognition, a small, quantized wake word model can run continuously on a smart speaker or wearable device, using very little power while waiting for a specific command. This on-device processing not only improves responsiveness but also enhances user privacy, as sensitive data like audio or images never have to leave the device. Beyond native mobile apps, TensorFlow is also making AI universally accessible through the web with TensorFlow JS. This library allows you to define, train, and run machine learning models directly in any modern web browser using JavaScript. This eliminates the need for users to install any special software. The 2025 release brings improved support for web GPU. The spectrum of edge deployment even extends to the smallest of devices with TensorFlow Lite for microcontrollers, demonstrating TensorFlow's commitment to delivering AI everywhere. Section 6. Conclusion. Your path forward with a modernized TensorFlow. In summary, TensorFlow in 2025 is a more powerful, flexible, and user-friendly platform than ever before. It has embraced simplicity on the surface with the deep integration of Keras 3, while retaining its formidable strength under the hood for large-scale production-critical workloads. The introduction of multi-backend support liberates developers from framework lock-in, fostering a more open and collaborative ecosystem. Performance has been supercharged with advancements in XLA compilation and mixed precision training, helping you iterate faster and reduce costs. From scaling massive models with dTensor to deploying tiny models on microcontrollers with TF Lite, the framework provides a comprehensive end-to-end solution for nearly any machine learning challenge. The practical impact of these updates is clear across a multitude of domains. A team working on natural language processing can fine-tune a small language model on their private data, and serve it cheaply with TensorFlow serving to power a customer support chatbot. A mobile developer can use a pre-trained vision model from TensorFlow Hub, export it to TF Lite, and build an offline feature for sorting images on a user's phone. A researcher can prototype a novel architecture using Keras with a JAX backend for maximum speed, then hand off the same model code to an engineering team for deployment on TensorFlow's battle-tested infrastructure. The tools are there to help you build and ship faster and more reliably. So what should you do next? Your path depends on your goals. If you are new to machine learning, now is the perfect time to start. Begin with the official Keras tutorials. Train your first image classification model, export it to TF Lite, and see it run on your phone. If you are a product builder, it is time to modernize your stack. Ultimately, TensorFlow's evolution in 2025 is guided by a clear vision to empower builders.